What's up, guys? Welcome back to the podcast. Today we've got a special guest from AudioQuest, Mr. Garth Powell. Garth, introduce yourself and could you give the audience a little background on what you do and where you've been?
Yes, I'm head of engineering for AudioQuest in the Quest Group. I've been there now for about 7.5 years. Prior to that, 16 years with a professional audio and broadcast company called Firm Sound. Uh, I was a lead design engineer for 14 of those 16 years, and I created the custom install and consumer division, as well as being responsible for most of the premium professional music industry and broadcast uh, components as well. The things that I am known for primarily because of that background have to do with so-called filtering or conditioning AC power. But I'm an analog engineer, and from the time I was a small boy, I was apprenticing with broadcast engineers long before electronics school, long before university, long before any engineering studies. So, been at this quite some time. I'm 57 years old. I got started in the industry at 15. But I've designed everything from condenser microphones to loudspeakers and every bit of electronics in between. About the only thing that I'm not, like I would say, what I would consider competent in would be having designed advanced digital filters, circuitries, or a DAC. I'll leave that to other constituents and friends of mine like Gordon Rankin.
So you mentioned that you did work at Furman, and I had mentioned that I own a few Furman products, and from my ears, they definitely made a difference in my home theater at least. And you're also working on some of their power conditioners at AudioQuest as well.
Yes. Well, actually, the interesting bit about that history is that about, oh gosh, maybe at this point it's been, like 15, 16 years at least. Um, there was a there was a brief period where AudioQuest had desired to get into the power regeneration conditioner filtering business. It was considered at that time with many of their competitors to be, like something that a lot of their other cable manufacturers were also doing, and a lot of their dealers were saying, like, when are you going to do power? When are you going to do power? When are you going to do power? Uh, but our founder, Bill Lowe, that wasn't really his specialty, and he is never willing to do something just for marketing or sales reasons. He won't get into a market unless there is something that he can demonstrate that shows why the presence has been earned. It has to be of value. It has to be for the price. Like at least as good, if not ideally better than anything else in the price range, or he's just not even going to consider it. And he just didn't really feel like he had the expertise. So at the time, he asked his sort of second in command, vice president of product development, Joe Harley, to purchase every power conditioner known to man around the world. If you could get a 120-volt USA version of it, bring it in. Nobody does this. I mean, magazines don't do this. The best ones don't. They can get in everything. I had reversed engineered a lot of things at Furman, but I never had this kind of a budget, and I never could have gone to my superiors and say, "Hey, there's this little niche company. Their piece is $6,000. That they work out of their garage, and I'd really like to purchase one. We can sell it later and bring it in so I can test it, reverse engineer it, and learn more about it." They just like sort of chuckle and say, "Get lost." Um, AudioQuest did this. It was the only time that ever been done that I'm aware of. And what they were specifically after was finding somebody that they might be able to OEM or partner with. So they went round and round and round and round. What they found at the time was most of the things that they tried made the sound worse. They finally got around to Furman after they'd tried all the things that were uh, the most likely suspects that the audiophile press, had reviewed and reviewed well. They finally got around to the reference series, particular from Furman. Those were my designs, and were kind of shocked to discover, wow, these really work. Everything's better. They wanted to know more about it. At that time, they didn't know who I was. They didn't know much about Furman. It's just a completely different market. So they reached out. There were a couple of people in common because at the time, their head of sales and our head of sales were old friends. They tried to work out an OEM deal. That kind of fell through. But the upshot was both Bill Lowe and Joe Harley spent a lot of time talking to me. And what they immediately did at the end of all of that was offer me a position, which I was very flattered. In many ways, being an audiophile from the time I was a small child, I felt like it was a better fit, but I'm very, very loyal pup. And it was at a time where I was just getting our new lines, in particular our consumer line and our custom install line at Furman started. I'd be letting a lot of people down. I just couldn't do it and wouldn't do it. So I said, thank you very much. And their attitude was like, well, it's a standing invitation. Like, but when you're ready, you got a place here. And I thanked them profusely and kind of forgot about it. And then, I helped with the rest of the team at Furman grow. But like a lot of corporations, what happened there was that we got sold, and then that gets sold again, and then that company goes public, and all the management changes and so forth, and all of a sudden, and it's the old story that everybody knows. The larger the corporate takeover, the more eventually they start to interfere, and then it eventually just got to the point where, well, I love the people I'm working with. I'm not sure that I'm going to be working with most of them 5 years from now, the way this is looking and restructuring. And worse than that, I don't think I'm going to be designing a new product ever again or anytime soon, because to be fair to them, they've just got bigger fish to fry. They've got a lot of failing parts of this line that they've got to bolster up. And my part of the pie was too small. So it just became a situation where I looked at it, I kind of thought, let's take a chance on this. And I moved from Northern California to Irvine, California, which is Orange County, Southern California. And I'm so glad that I did. It was culture shock, but it was unbelievable. Every place I've ever worked, and this is typical of any corporation, here's your health, here's your medical, here's your desk, here's your office, like here's everybody you work with, sign this here, and like get settled in, and then within 2 weeks, well, how are things going here? We need the new product line in 6 months, and it's always about price. It's always about hurry up, hurry up, hurry up. We got trade shows coming on. We've got reviewers, like that are queued up. We've got expectations for the third quarter. We want to get this ready for Christmas. Let's get going. Bill was like, I don't care when the product line's ready. Don't waste any time, but take all the time you need. I was given unlimited virtual resources, vastly better equipment to work with, a seemingly unlimited budget compared to any place that I'd ever worked before. And and every time I thought the things I normally would have self-edited in the past, thinking they'll think I'm crazy for even bringing this up. No responsible company would ever allow this to be manufactured. It's going to be too hard. He seems to be open-minded. Let's bring it to Bill Lowe. He said yes every time. And this allowed me, along with spending hours and hours and hours and hours talking to Bill and downloading everything about what he knew about cable design, ended up affecting a great deal of the technology that was developed for Niagara. I could have and would have been allowed, and they would have been happy for me to take what I'd done at Furman at the upper end and just modified it, just improved it slightly, just refined it a bit. But instead, even though I'm building on some similar principles, I was allowed to start with a clean piece of paper and to just start with, assume everything I know is wrong, start again. What can I do, like with unlimited support, unlimited resources, no one's going to tell me no, go. And that's the genesis of Niagara.
And the entry level model starts at the 1000. Like, what does that get you? And as you go up the line, like, what other benefits as you go up the line here?
The whole thing is that, yeah, there's as you move up, it's kind of like standard to some other power lines. As you move up from the 1200 and 3000 to the 5000 and 7000, yes, there's more outlets. Yes, there's more RMS current capacity going from 15 amps to 20 amps and so forth. But look, I could care less. I mean, that's something that's needed as a practical matter to know about. I can talk about the specs. I can talk about the marketing features. I never care about that so much as the basically the genesis of this whole thing. Why do you care about owning a box like this in the first place? Because the fact of the matter is that you could take everything you own, plug it into a $20, like surge strip, or strip even without the surge protection, and be done with it. I promise you, everything you own will turn on. If you live in an area that's not lightning prone like the Keys of Florida, the fact of the matter is that it will probably work reliably for the next 10 years. Why on earth would anybody buy a box like this starting at $1,000 and going all the way up to $9,500? The reason is twofold. One, because if you've got a premium audio video system, we've got a level of induced radio frequency noise that we've never seen in history until about the last 15 to 20 years. I'm talking about cellular towers, Wi-Fi, Bluetooth, anything along those lines. The frequencies are smaller, or basically higher in frequency than they ever were before, and therefore their sine waves are smaller. We've always had radio waves. I mean, that's been with us since the electronic, foundations of the 1920s. But the difference between 1920s all the way through the early 90s going into this millennium is the frequencies have become so high, and therefore the noise waveform so small that your conventional shield in a cable, your conventional metal chassis, it's no longer good enough. It's not even close, because that noise can just what's called capacity couple directly into the circuit. Why do you care about that? What the hell is Garth talking about? I'm talking about radio waves coming in, and I'm not talking about hearing your local FM station modulating your system. I'm not talking about eavesdropping on someone's conversation. No, it's coming in as noise. But what that noise does is it masks your low-level signal. Like this. I don't want this. I want this. That's why I care. Because if you've got wide dynamic range, if you've got high resolution audio, you got high definition video, that's about a massive amount of dynamic range, a massive amount of signal. And the thing that's different between a boombox and a great system, what's different between your laptop and a great video system, is its ability to get all of that resolution, all that definition, all those details, all that saturation, all of that depth of field right in audio, the transients, the harmonic series, the extreme highs, all that stuff is very low in signal level. And the good news is the best AV systems were designed to reproduce it, but you got to give them a fighting chance, because this is the foundation of what you're doing. You got to get the noise out. It's not about what people think. It's not, oh, well, I'm hearing some hiss, so you're going to get rid of the hiss. It's not about that. It's not about, oh, is there some hum? We got hum. We got to get rid of that. That's usually a ground loop. But no, that's not primarily what this is. This is a noise that's insidious. You don't know how much you're losing until you see and hear the effect of taking it away. This is foundation. The other thing is that every AV system is going to have a power amplifier, because you got to run your speakers and you got to listen to this. You got a power amplifier. Power amplifiers are different than everything else in the system for one reason and one reason only. It's the only thing in your system that's a variable power supply. Everything else is fixed. Whatever it says in the spec sheet, if it says I'm drawing 1.2 amps at 120 volts, it never moves once you turn it on and stabilizes. That's what it's going to draw. Power amplifiers move up and down, and they modulate all over the place with your audio signal. The reason that matters is because most devices that are so-called power conditioners, power regenerators, power filters, isolation systems, they make the system worse. The power amplifiers, at the very least. Most power amplifier manufacturers, premium ones, don't want you to use a box like this. And they're right, because most of these devices make them worse because they raise what's called the AC impedance to their power supplies. And that, even though they might be filtering, which is good, even though they're protecting, which is great, the ultimate goal is to make sure that when they need current on demand for an audio transient, they have the ability to get that current from your utility supply. If you do anything that blocks that, impedes that, gives a level of resistance to that, that's going to be a problem. What I've been working, like with for many years now, is something I started with Furman, refined with the Niagara series. It's called transit power correction, and it's essentially about creating a buffer in front of the power supply of the amplifier to where I can give it a current reservoir, 3,000 to 55 amps, and 5,000 and the 7,000, it's 90 amps peak. And essentially, we're making that amplifier better by allowing its power supply, which is where everything starts, to work at nearly 100% efficiency instead of waffling about at around 80 to 85. So those are the two things that I'm really concerned about. I'm concerned about current compression, making the amplifier work as best as it possibly can for the high current banks, and then for everything else I own, whether it's an audio, video, or computer peripheral or digital product, making sure that I'm reducing the noise as much as I can, and that I'm doing it as evenly or linearly as I possibly can. I talk about this all over the world. I've been talking about this for decades. It's the same story. I just keep throwing more ideas, more technologies, and more patents at trying to achieve those two things. And if I can achieve those things, then everything else is just window dressing. I can talk about patents like ground noise dissipation. I can talk about transit power correction, a little bit of that I just did. I can talk about all the proprietary parts that we use, like directional wiring and different things that we do and so forth. I have lots of things to boast about. But the fact of the matter is that to me, that's window dressing. Anybody that has a product and has a sales and marketing team is going to go into great detail with these ideas. But to me, if you don't understand at a foundation level why you need any of this in the first place, why do I care? That's always my point is I want to be infinitely practical. Why am I going through this exercise in the first place? Why on earth would I ask, like a friend or a colleague to spend this kind of money? Because with the Niagara series, you start at $1,000. It's very reasonable for what it does, but I can assure you, $1,000 is a lot of money. It certainly is for me. And I would feel horrible asking, like a friend or a colleague to invest in that if I didn't think and could prove this really is worthwhile. This really works if you've got the budget.
How do you feel when people say, why would you need something like this when shielding and all that inside the amplifier or receiver or your television should already keep that interference out? Like, what are they doing wrong that these products are doing right? You know what I mean?
Oh, well, they're doing everything. They're doing everything as best as right and as best they possibly can. But they've got a couple of things to consider. One, when you're making, even the best preamplifiers and amplifiers and so forth, you still have competition. You still have price considerations. Everybody at the top end talks about cost no object, but until you start really getting up into the stratosphere, that's not entirely true. And then also people just have, different engineering priorities and different, like base level knowledge. But when it comes to, something like a Niagara, if they knew how, they could take a lot of these technologies, they could put them into their amplifier. But, if you've already got an amplifier that's 70 pounds and you want to avail yourself of what I'm doing, say, in a Niagara 5000, well, now your 90-pound amplifier is about to weigh, like 140 pounds, and it's about to nearly double in cost.
Mm-hmm.
And you would hear the difference. It would be worth it, but and you'd also have to know how to do it. Some of these things we've got, patents on, so they also have to license from us. But the thing is that in theory it could be done, but I just have seen through the years, nobody ever, like it really does. But the thing is that they do great work. The big misconception, and I believed this prior to starting with Furman, the way I was trained through all my years through engineering, electronics school, and through all the people I apprenticed with as a child, was that build a proper power supply, use good parts, do it well, especially a good linear supply and so forth. You can hook up the oscilloscope probes to it. Nothing's getting through. You've done your job. We're good to go. We're perfect. Well, no, it's just the way you're measuring this. You're not seeing a lot of things. And then plus, as I mentioned, things have changed in this new age where you've got cellular towers, Bluetooth, and and so forth. So it's gotten to a point where you need to throw everything you can at an audio system and a video system to get this to work at everything's full potential. But these power supplies that are in your amplifier, your DAC, your preamplifier, your phono preamplifier, your television monitor, or your projector, those are power supplies that where the power comes in alternating current, AC, that we get from our utility, and they immediately go through rectification. 90% of what's in that power supply is for direct current, like a battery, DC. They're great DC supplies. They're not great AC supplies at all. That's the part they all overlook.
I'm surprised you guys don't make a power regenerator. You guys looking into that?
Absolutely. I looked at this many times, and I built them in the past, particularly when I was at Furman. I would never make one now that I'm at AudioQuest. There'll never be a regenerator for Niagara for a very simple reason. They don't work for what my aesthetic values are. And it's interesting because coming out of electronics school or coming out of engineering, I would look at this and kind of think, this is perfect. This is exactly what I want to do. I can put, again, my oscilloscope or a power meter up to wall outlet, see that my perfect 60 hertz sine wave is anything but a nice looking sine wave. It's littered with noise. It's chopped. The wave peaks look entirely wrong. Sometimes the frequency is not even quite 60. And so it would just make sense. Wow, I can make the voltage unwavering, a perfect 120 plus or minus a tenth of a volt. I can make the sine wave gorgeous. I can get my harmonic noise down to, like a tenth of a percent. Fantastic. My job is done. And I would have believed that until I really started researching this to the level I had to when I was with Furman. Because the first unit like this that I ever took home, that I had nothing to do with designing, that had been done by the other team of engineers when I first started there, I brought home and the thing failed miserably in my system. It sounded worse than a basic strip. And I needed to understand why, because it was something that in broadcasting and studios, people had been loving. The specs looked good, but there were fundamental things about it that didn't sound good. I needed to understand why that was and how to measure it. Well, again, you have basic problems. Once you understand that a lot of this is about noise, not about, because see, here's the thing. A perfect sine wave would be great, except that I'm about to go into a component that's going to turn alternating current into DC via rectification, without exception. The only thing that's going to, in your system that's going to run off AC is if you got an old-fashioned turntable that runs off an AC synchronous motor. Other than that, everything's DC. So if that's the case, trying to get 4%, 10%, 20% harmonic distortion on my sine wave, I'm about to turn that into 0% harmonic distortion direct current. So that didn't really help me much. And then, like perfect, like steady voltage, there are situations where that could be an advantage, but more often than not, I've got DC regulators in my power supply. I've got, like some components, they have switching power supplies that already have their own regulation inside those. So that's not necessarily helping me. So, well, what is it about, like regeneration, turning AC into DC and then making an, like a differential amplifier that makes the AC again, what's that doing for me? Well, again, you've got steady voltage, you've got very low harmonic distortion, the sine wave looks good. But what did you give up to do this? Nothing in science is perfect. Well, here's one problem. It's an amplifier. An amplifier has bandwidth, a frequency response. Well, a frequency response of a really, really good amplifier, say something like a Krell Duo 300. Okay, so what's its frequency response going to be? Let's say it's good from about 1 hertz up to about 250K. What's going to happen to the frequency response at 400K or 500K? It's going to probably be down about 100 dB. It's going to fall off rapidly. Its amplifier is no longer conducting. It's not doing anything at this point. It's well exceeded its bandwidth. So if you've got a regenerator and for 50 or 60 cycles, it's going to have a bandwidth like that too. And then the problem is that where's the AM band start? 540 kilohertz. And then where's a lot of the new noise we got to contend with today? How about 500 megahertz up to 2.4 gigahertz? Where is this, like incredible 100 decibels down, like common mode, like differential amplifier noise reduction system at those frequencies? Zero, unless they tag on to the end of it a very inexpensive, like passive supply. So I've got two problems now. One, it's not functioning well where the majority of my noise is. And then the second thing is that because it's turning off so radically, even if I add some passive parts afterwards, it's not linear, it's not even. That's a problem when I'm reducing noise, because I don't want to reduce noise at one set of audio or video frequencies by, like 20 decibels and go from this to this, and then in another quarter octave away, get rid of, like, wow, 60 or 80 decibels and go from this to this, and then a quarter octave, have a resonant peak in my system that adds 6 dB and go from this, and then for 23 octaves of radio, frequency and induced noise from my incoming utility line and appliances, be going from this to this to this. It's like putting a graphic equalizer, like 24 band or something like that on your system and having it constantly varying with dynamic signal drive at low level signal. It's the last thing that you want. So it's not going to be consistent in that regard. Going to an amplifier, a regenerator has a bigger issue. It's a power amplifier feeding a power amplifier. What do all power amplifiers have in common, no matter whether they're Class A, Class D, or anything in between? Well, that's that at 1.414 times the fundamental, or the maximum power output rated into whatever impedance, it's going to start to clip. Which means that approximately, if I've got, say, a 10 amp power regenerator, 10 amps RMS, that's quite a bit, like for a lot of systems. That's more than honestly, a lot of amplifiers are going to pull on average. But the problem is going to be the transient peak demands of that amplifier, which just really briefly, 10 or 15 milliseconds, could be 20, 40, 60, like about 70 amps peak. Very, very, very fast. It's so quick that it's not going to trip your breakers, because your breakers in your service panel are made to be slow. But fortunately, they're usually connected to anywhere from a 100 to 400 amp supply, meaning your mains transformer. There's some resistance in the line, but basically it still works. So the problem with the regenerator is that I've thrown all that away because I've converted to DC and then back into AC. So if I've got a 10 amp RMS regenerator, that means at around 14 amps peak, I'm starting to clip. At 20 amps peak, I'm not only clipping, but my sine wave looks worse than what I was feeding to it, basically what it was being fed to from the utility. So the deeper you look at some of these problems, the more you see that no matter what you do, including what I do, is going to have a series of trade-offs. So as an engineer and as a designer, what are you going to do to strike the best average? And because I need to do that, I won't touch a regenerator.
So would a voltage regulator be a better alternative?
Made voltage regulators for years at Furman. And we made some of the highest current ones with like electrical zero cross switching in the industry, still used to this day, still depended on. And you've got to look at the application. If I'm doing live broadcast, if I'm doing live sound for a concert, if I'm dealing with the backline, uh, in a situation like that where I can't depend on the power that's being fed and I've got to know that the show must go on without interruption, that's a great technology and you got to do it right. For a home, don't want it because not always, but 99% of the time, as I kind of referenced earlier, your components don't really need it, don't benefit it from it, but even if I kind of thought, well, even if it just occasionally it might, benefit from it, why not do it anyways? Well, the reason I wouldn't do it anyways is that again, I can't create something and not have detriments that come with it. The detriments that come with a good regulator are noise. Period. There's no way to do it without that. And even worse than that is even if you could find a way to minimize the noise, you're going to raise the impedance dramatically. So you're doing your power amplifier no favors. It's got two massive strikes against it. We made some of the best voltage regulators in the industry while I was at Furman. And for the people that were doing live work, outdoors, diesel generator, that was the go-to tool. If it was a custom install person, if it was an audiophile, I would beg people not to use one.
You're making me
Put the
feel
right
bad.
tool in the right place.
You're making me feel bad because I bought one.
I'm sorry.
All right, so back to power conditioners really quick. So now because we live in a technology age where there's a lot of Bluetooth, a lot of receivers have all these wireless connections going into it, there's a lot more chance for interference and noise coming into your line, to your signal path, which is where these power conditioners will come into play. And I, for one, I've always used power conditioner. I've got Furman, Panamax, and Furman, and I've always heard a big difference. So I can say that yes, definitely worth it. And glad to see that you're over there doing stuff for AudioQuest with the Niagara series, which look very nice. But the question for you guys in the audience, do you guys use power conditioners? And if so, do you use Panamax, Furman, AudioQuest? What do you guys use? Leave a comment down below. All right, let's move over to cables. So, speaker cables, Mr. Powell, we're looking at some affordable stuff, affordable options, all the way up to the ultra high end mythical creature series. Just speak about the options that are here from the entry level series all the way up to the best stuff that you guys make.
Okay, well, you could start with some of our entry level, such as the Rocket 22 or the Q2, and like a 10-foot pair. Basically, you can get into our line for a 10-foot pair for about $230 retail. And we just go up incrementally from there, like approximately, like $100 or $100 plus intervals, just going up and up and up. And after a certain point, it's $1,000 intervals and so forth. And, there's theoretically something for every budget, again, from a little over $200 all the way up to our Dragon, which is at the, ultra high performance nosebleed section, our by-wire combo set at about 15 feet is around 80 grand. But but that's for people typically where you're talking about a low to middle six-figure system. So it's always in relationship to what's the a proper tool for the job. Obviously, if I have a very very high performance sports car, probably makes a great tire. If I've got a Honda Fit, that's an inappropriate tire for that car, and it actually won't even make it work better because it wasn't designed for that kind of suspension. It wasn't designed for that kind of wheel and that kind of car. You put the right tool in the right place, but you don't need to spend a lot of money. Now, that said, $200 for a pair of cables, if you're used to lamp cord, if you're used to something that you got from the electrical section, say, at the hardware store, that's still substantial. That's still probably anywhere from, a 3 times to 4 times more, like at least twice as much. as you would thought you needed to spend. Will you still get sound through something that's theoretically inferior? Yes, you will. Will it be nearly as good? No. Now, there's tons of people that will dispute this all day long. You'll find things on YouTube and so forth because, Shane, we discussed this earlier. There is never going to be an end to the, doubters and trolls that have been around for decades talking about there's no difference in electronics. I've got an oscilloscope. I've got a spectrum analyzer. I've got a signal generator. I've got an audio precision. None of these cables make any difference at all. Just get the same thing that we've been using for 50 years in professional audio. That'll do you fine. And, these people are all they're full of it. It's all a bunch of nonsense. And I got a confession to make. 25 years ago, that would have been me. I didn't know any better. And I was smart. I was well educated. I tried better cables when I was, like a kid at I'd heard the differences, but I always kind of assumed that, well, you don't want to use junk, but after a certain point, how much of this is just throwing money at the problem? And are we really splitting hairs? Because I had a little bit of what I call the engineer's disease, which is that all I knew were the tests I was trained to perform. And I knew for a fact what a lot of these doubters say, that if I get a signal generator and I get an oscilloscope or a spectrum analyzer, audio precision, and I put a cable from input to output and I subject it to the rigors of typical analog or digital tests that would be done for a preamplifier, done for a power amplifier, you're not going to see a lot of differences. You really won't. And in fact, you could literally use baling wire that they'd use out on a farm and actually get pretty respectable results at audio frequencies, because compared to a lot of radio frequencies for broadcast, it's in some ways, for tests like that, it's not a critical standard and it's not that hard to meet. But when you start listening to all of these differences, and as in science, performing one variable change at a time, you start realizing how much all these different technologies or topologies for a cable make. And when you go through that, then it becomes, why is this? Now, one of the problems in our industry is that for years and years and years, it's kind of been well-meaning people, but that it was sort of philosophical, it was sort of theoretical, and kind of like, well, we know what we hear, and that should be enough. And in a sense, it is. I respect that, because science starts oftentimes with an hypothesis that no one's able to prove yet. Unfortunately, again, I have the engineer's disease, and I'm also stubborn and I'm also obsessive. So I'm going to work and work and work and work until I can measure it, until I can prove it. And the reason I want to do that is not to validate myself to others nearly so much as I want to learn. And because if I can understand why something works or doesn't work, that informs the next series of designs. And I can improve and I can push the art form or the science forward. So the whole thing that, for me, is that when you look at the way this has been measured for years, where you're taking a single signal, be it sine wave, be it square wave, or maybe two, or maybe three, from like one or two signal generators, pumping it down, like a bit of wire or cable, and then coming out the other end and measuring this. Everything looks pretty much the same. The problem is that application. Is that what we're going to listen to? No. Is a signal generator the rest of my system? Is an oscilloscope or a spectrum analyzer a speaker? No. If you want to know what an interconnect cable, what a speaker cable, what a digital cable, what any of these cables are, or even a power cable, are really doing in an audio video system, here's a thought: put it in an audio video system. Put it in a recording studio system. And then measure the throughput from the beginning of that system to the end of that system, where the only variable is the cable against a reference. Same levels, same input. And instead of the input being what you would never do, which is a single or two signals at once, steady state, no, or tone burst, no. Actually, audio or video content, maybe 10 seconds, and do a differential or a sum file. That, to be fair, would have been nearly impossible to do well when I started, as a kid, like 40 plus years ago. Today, in the digital age, it's child's play. You can do this, like in any good laboratory or studio. I've done this test in mastering suites. I have up in our website through Power Demystified. There was a number of tests I did for the Niagara series and our Thunder AC power cable, where we went into Bernie Grundman mastering in Hollywood, and we showed all the work. We showed everything that we went through, how the test was performed. Any other scientist, any other engineer can go in and perform the same test. And then we took the sum files and we put them, the spectrum analysis, up for everyone to see. And, absolute conclusive, proof that these technologies not only make a difference, and not only that they work and do what we claim that they do, but it's a test that's real world, because you're looking at that one variable in a real system, not a laboratory condition that will never match or meet what you would put that cable through normally. So that's, again, for me, it's never about, well, we use this kind of conductor. Well, we use this kind of insulator. Well, we use these kind of patented technologies. Those matter to me, they do. But whether it's, like our K2 or Rocket 22, going all the way up to our Dragon, every series and everything we do in between, all the way across all different uses of cable. If it's got conductive material, we're building on a lot of these same foundations. And one of the foundations is I need to know what the hell I'm doing. I need to know how to study it, how to measure it, and see what the problems are. Because one of the things that I can tell you is that, believe it or not, and I can prove it, so I believe it because I can prove it. One of the biggest, issues with an interconnect or a speaker cable or a digital cable, input noise. It's the same story as Niagara. The noise is so pervasive, it's so bad. This is causing, in the case of the speaker cable, it's contributing to the system's what's called transient intermodulation distortion. It's a masking effect, that it's gobbling up low-level information. It's affecting your peak-to-peak transients by way of distortion, and also masking some of that. Therefore, your perception of volume, your RMS volume, doesn't change one iota. It's physics, it can't. But your perception of volume is not based usually on a nice, even sine wave. No, it's based on the fast transient and the peak-to-peak swing, and not compressing or limiting that peak-to-peak. Those are some of the things that we work to get as close to our ideal. And our ideal cable, be it a speaker cable, a digital cable, an audio interconnect cable, or power cable, is no cable. That's the only perfect cable. Get rid of the cable. Cables will always end up giving you less of the signal that was originally there, of the power transfer was there. It's physics. All we can do is transform energy or lose energy. We can't create a damn thing. So our whole thing is that when I create speaker cables, my reference is a 2-inch, 50 millimeter set of cables. And I'm trying to make an 8-foot pair, a 10-foot pair, 12, 15-foot pair, as close to that as I possibly can.
Can you touch on this? Because I think you guys have like the patent on this here. The DBS.
Yeah, that's that cute little, like what we called a battery pack for years. Now, the ones we do these days, I went in and did a refinement to what our founder Bill O originally created, and now it also has a radio frequency noise trap inside it to help. But essentially, this does two things to a cable. We do this on our premium cables. This is not something that you have to do, but it's a refinement. And it essentially helps with a couple of things. If you've got an audio cable, one of the problems of the insulator between your positive and your negative that keeps minimally the two conductors from shorting out, blowing up your amplifier if it's a speaker cable, and not passing any signal anymore. So we don't want those things. So we got to put some kind of insulator around them. Well, that insulator is also what's called the dielectric. It's a type of capacitor. Well, it's a very small one, but the problem is that these signals essentially transfer as they're modulating down the length of the cable. They're essentially the positive leaking into the negative's leaking into the positive. It stores the energy, release, store, release all the way down the length of the cable. And this is something that's unavoidable, but it's something that is a distortion that you don't want. When you put a bias on that insulator, or what's called the dielectric, you minimize some of the distortions that come from that. So that's reason one. Now, with another new technology that I developed and brought to AudioQuest, zero, all caps, which is zero characteristic impedance, not zero resistance, zero characteristic impedance. We still use the DBS, but in that case, we don't have any longer that dielectric effect between the positive and the negative, because we electrostatically shield it and eliminate it, or eliminate 99% of it. But the DBS, or dielectric biasing system, what it does there is it takes the filtering or noise dissipating effect that you get from that insulator, and it optimizes it by putting a dielectric bias on it. One of the things that audiophiles and videophiles, cinemaphiles have noticed for years is that they will buy a premium system and they'll be impressed the day they take it out of the cartons and hook it up. But they also notice that in 2 weeks' time, a month, 2 months in, it keeps looking and sounding better and better and better and better. Why is this? There's a number of reasons. One of them is that a lot of the active circuits start to get into stasis in terms of their ideal temperature. But the other reason is because you've got all these dielectric effects, and you're starting to what's called cook them or burn them in. These are electromechanical devices. Everything is. It doesn't matter if it's a cable, doesn't matter if it's an amplifier, it doesn't matter if it's a preamplifier, it doesn't matter if it's a DAC, it doesn't matter if it's a television. They all are electromechanical devices. It's no different than a car. Again, if I get a premium sports car, if I get a Porsche Carrera, and I take it right off the factory floor, am I going to take it off the factory floor and go out to Le Mans and floor it? Not if I want the engine to survive. No, I'm going to coax it along and slowly bring it up. And ultimately, I'm going to, if I'm going to race it, I need to make sure that I've floored it a number of times safely, so that I've, done the work to that engine to make sure that it's used to working properly at every rotation, per minute that I could do. It's basically setting or, seasoning that motor. It's no different for electronics. Everything pretty much works the same way. Our bodies are machines. We need to exercise. We need to stretch. All these things, work off similar principles.
So the battery pack is not connected to the actual cable, the conductor itself. It's connected to the insulation, the jacket. Correct on that?
It charges the insulator. So there's a positive and negative, or anode and diode. So the negative side is usually connected to the shield, if the cable has a shield. But the anode or positive side is a very, very skinny wire, inside the dielectric, that's connected to nothing but the dielectric bias system.
Okay. What else we got here? And talk about really quick here. I know you offer perfect surface. What exactly does that do, and how does it help?
So here's the thing. People have talked about ideal wire for a number of years, and we are not. AudioQuest is not alone where this is concerned. When I first got started with my first, experiments with premium wire, back in the late '70s, early '80s, there was companies long since gone now called Fulton. There was Monster Cable was one of the first to commercially really jump on this and do this in a big way from a marketing distributed, like a way. And everyone would talk about oxygen-free copper, and then that gave way to how much purity there was in the copper, and then people, talked about the crystal structure inside the copper, and then there were all these different mines and how which, like that was done, and there was a lot of emphasis put on that, and then people started experimenting with very, very pure silvers and so forth. And I was always curious about this. Well, it seems to, if you listen to these things and it's the only variable, it seems that, generally speaking, the purer the conductor is, the better it seems to sound. But, kind of like, why is this? Well, what it really all has to do with is the fact that, once again, if you do a very simple test, you could use just the crummiest conductor in the world, and it's going to pass 20 hertz to 20,000, kilohertz just fine. What actually a lot of this has to do with, the wire itself, the conductor itself, will make a difference at higher frequencies, to be certain. And there's things like skin effect and so forth, and phase versus frequency, that have been known since the 1930s and well documented. But again, as it happens, a lot of this has to do with noise and the way noise is induced into the cable, because the noise is usually from radio frequencies. It's very high because there's something called skin effect. It goes along the outside surface, like not just the skin, but the crystal structure, because these wires are cast, they're originally cast, and then they're drawn into the skinnier wire size that you need from a cast rod. So the defect with every conductor material that there ever was is that when you draw something, you're creating all kinds of distortions in that porous cast structure. And in fact, with modern machines that are moving at very, very fast, efficient rates, if you were to look at the crystal structure of the casting right underneath the skin surface, you'd see little serrations as you pull away. Now, the thing is that this is just kind of like a normal bit of nature. If you look at a human hair coming out of our follicle, or say a horsehair, why do people use horsehair for a bow, for a violin, a viola, or a double bass? It's because if you look at it under a microscope, there's old serrations for when it pulls out of the follicle. And then in those instances, that's good for friction. They put rosin in there. The serrations absorb the rosin, and you've got something that works really, really well for what you're trying to use it for as you're playing that string instrument and making it vibrate. So for our purposes, the problem is that you've got like a steak knife. You've got the serrations pulling away from where that metal is drawn through the machine, and it's kind of stacking in one direction a little more than the other. And this should not make any difference at all for most of the main frequencies that are going through it. Plus, if you've got an audio or a digital circuit, the way current works in a system or a cable, it goes from source to load, or the electronics you're starting with to where you're going to, down the positive or the high, and it returns the opposite direction through the low. But as it turns out, a parasitic radio frequency noise doesn't adhere to that. It just skates along the top. And because you have a situation where it's going to, always look at path of least resistance as it skates along the top, because that parasitic noise signal is very high frequency. Therefore, the outer surface, it says, okay, do I go this direction, that direction, or just sit here in a circle? Oh, there's a little less, resistance if I go this direction. So by trying to make wire that is as minimal as possible in terms of these little serrations and imperfections, you have less distortion, not only for the main signal that goes through, but also, just as importantly, for any of the induced noise that you're trying to get rid of. But then if you go a step further beyond perfect surface copper or perfect surface silver, and you do something that we've been doing for many, many years now, and you test each roll of conductive material, copper, silver, plate, whatever it is we're using. We do this even to our drains and a lot of our power supply leads inside of an HDMI cable, for example. You can take that defect of any conductive wire or material, and you can send that lower resistance path to the part of the signal, input or output, source or load, to the area that's going to do the least harm. This is called directionality. If you look at AudioQuest cables, they always have arrows on them, and that shows the direction of these conductors, where we're choosing to drain that noise. And this is part of our noise dissipation technology, or part of a noise dissipation system. It is one of the things that I don't know for a fact, but I'm pretty sure we still are kind of alone at doing, which I understand because it's a hassle and a half to do this. The test that's done, used to have a partner, but he retired this year. I'm the only person currently who does this. And there are weeks that I really wish I didn't have to, but the rewards that we get from incorporating that in all the cables, actually every inductor inside of Niagara goes through the same process. And the major difference is phenomenal. We'd never not do it. It's too important.
And I know you mentioned the obviously perfect surface. So would you say that the solid core cables are much better than stranded cables?
It is the aspiration that all our cables are designed towards. In a perfect world, that's what I always want. In a perfect world, if I could get away with it, one strand, solid. That's the purest. But we live in the real world. There are times when, for reasons of flexibility, getting enough conductor together to give us an ideal DC resistance for current transfer, for example, the combination of needing to be flexible and needing to have enough conductor, there are times when one solid conductor or maybe even a bundle of insulated solid conductors are simply not practical. And so when we do that, we go for stranding, but we don't just give up and say, we don't have a choice, stranded. Let's just bundle a bunch of conductors like everyone else, and that'll be it. No. We use concentric stranding, which is a geometry that minimizes the distortions that are inherent in stranding. So anytime that we have to go to another tool in our toolbox of design, we always try to minimize any potential damage. We're always trying to optimize for a given application. But the thing is that, for example, if you look at for power cords, for example, the mythical creature, and Storm series. Well, that's a fantastic cable, but they're kind of French braided. They're very large. They're flexible, but they're kind of like a little bit of work to deal with. If you're an audiophile, if you got a great system, like I need 4 or 5 or 6 of these or something like that, you got an open rack, no problem. Then all of a sudden you got the customers like, I really love what you created. I hear such a difference. I really want to use this, but I'm in this real tight space and it's in this really beautiful, burlwood, cabinet that I had made for me, and I've only got this much space between there, and I really need a cable that's a little skinnier, and I need it to bend quickly and so forth. And this other, piece just won't work. Do you have anything for me? Yes, we do. We get into our, Storm series or our NRG system. Now we've got something that looks more like a conventional power cable, and it's, it's much skinnier. It doesn't have the braid, and it's much more flexible. Why is it flexible? Because we've got concentric or true concentric, stranding, coming close to the ideal of a solid core, but still allowing us to have a form factor that's a little bit more practical for applications that demand it.
What else we got here for you? Now, would you say that since you guys do have different price points, how important do you think the actual your overall system plays with picking your speaker cables? Obviously, you're not going to buy $20,000 speakers and maybe buy a Rocket 33. You probably buy something more in the lines of a Folk Hero or maybe even the Mythical Creature series. Do you think a more resolving system benefits more from those higher end cables?
No. It's interesting. This is a situation where I wish our founder, Bill Lowe, was here, because boy, can he speak to this. He fought that perception for so many years. And he finally decided, Bill, forgive me, I know I'm going to get this wrong, because he knows the dates I don't. I think he started doing this in the very early 90s, maybe even the late 80s. But what he did was he got tired of hearing that from people that just kind of always assumed that, like, well, I see that you have affordable cables. I see you have a lot of expensive cables and things in between, but hey, I mean, I like my system, but it's not a top tier system. So clearly these differences are for the audiophiles, the extreme cases, the lunatic fringe at the top. For mine, I probably don't need to worry about this, right? Wrong. No, what he did was he started going around with a boom box, an old 80s vintage JVC boom box. And it was one that had the speakers that could be taken off of the cassette player and the radio, and or the CD player and the radio, like at that period. And, like about where he could disconnect, like about the stock speaker wire that was there that would have been junk, like put, like connectors on either end so that he could plug in our least expensive speaker cables, other people's speaker cables, basic lamp cord, and go all the way up to the top. And what people heard on this little $200 boom box was dramatic sound differences from the bottom of our range to the top of our range compared to other things that were well regarded and basic lamp cord, basic speaker cables that everybody assumed that, like, well, no, obviously you need a great system to hear these differences. No, he could demonstrate to you this on the most basic system. These differences are fundamental. They're foundation level. You can absolutely hear them. Now, am I on the other hand saying that every man, woman, and child, needs a $10,000 pair of speaker cables, particularly when they just, invested mightily in a $2,500 a pair set of speakers? That's crazy. I'm not going to tell you not to do it. I'm certainly not going to tell you that you won't hear it, because you will. But generally speaking, I like to think 10 to 20% of your, your speaker budget or your system budget, put it towards the cables. And, like when you're putting a new system together. But, when you're on an upgrade path, sometimes, it's like we like to call, bringing home flowers to your system, and rediscovering all of your, your music or your videos, content again, and seeing things and hearing things you've never heard or seen before. And so that becomes a situation where sometimes you can justify spending a little bit more. It depends on what your budget is. You will always reap the benefits of it, but there's no shame in, this is what I can afford, or on the other side, deciding I just really want to shoot for the moon. I just got a bonus. Let's try this. Wherever you go, you'll reap a benefit. Anything that we do is solid value from the entry level to the top. It's always about this justifies its existence and its price point, or we're not doing it, period.
Mm-hmm. What do you say about the folks that say if you crack open a speaker and the cables inside the speaker don't match what you're buying?
That has been a frustration for Bill Lowe for the entire time he's been a cable manufacturer and designer and running the company. But again, and even many speakers that are theoretically price no object, even then they'll use cables that are far better than than typical, and they'll be from like known manufacturers that but it'll rarely be they're top of the line. It might be a $120,000 repair set of speakers, but the cable that's in it will be, something that's, like a middle price point from that particular manufacturer. Because even there, it's hard for the speaker manufacturers to think that beyond a certain level, oh, I really want to put all the money into the box or the enclosure. I want to really put all the money into the driver technology. I want to put it into the crossover design. This is wire, for God's sakes. Even if they've heard the differences, it's hard to get them to make that leap. We absolutely understand this. The good news is this: people often get into this false dichotomy about the weakest link syndrome, where, like, okay, well, look, if I've got crap wire going from my electrical box to my outlet, all's lost. So why have good, power cables? Why have a Niagara? Or, the opposite end of the system. If I've got, stuff that's barely better than hookup wire or lamp cord in the speaker, how can the rest of the stuff make a difference at all? Because it's not about that. It's about how much of the signal I can preserve. And all along the chain, I'm trying not to lose energy, therefore current compressed, and I'm trying to not lose energy to noise masking. It's like two, and obviously be faithful to low distortion transfer of the signal. But that's relatively easy to do. It's these other things that are incredibly hard to do and are so vulnerable. So even though I would like the wire in the speaker to be better, because you'd reap benefits from that too, it's not true that just because I can point to something at this point of the system, this point of the system, and that point of the system, to where, okay, well, if those are compromised, then that's my, lowest common denominator. That's my weak link. All else is lost. No, it's not lost. It'll still be better when you improve with everything that you improve all along the chain. We're trying to lose as little information as we possibly can. And even if that wire inside the speaker is responsible for losing 1 or 2%, that doesn't mean like, oh, if I've lost 2%, screw it. Let's just put, the same level of quality everywhere. Now I could be losing 20, 30%. No, let's get it back.
Isn't the wire that they use inside the speakers, isn't that taking into consideration the sound that comes out of the speakers? Like if you change the wire in it, wouldn't that inherently change its measurements or its sound characteristics for the better or the
Yes.
worse?
Yes. So this is like modifier and DIY people beware. That is something that is rarely, understood very well. If it is a relatively inexpensive commodity speaker, there's a good chance that, doing that modification would reap a lot of benefits. But if it's a medium to higher priced, or audiophile grade loudspeaker, the manufacturers, warts and all, have, because nothing's perfect, our cables included, they have done a lot of voicing of that system, and it becomes a integral, matched system. And you start changing variables, and you can possibly have some advantages, but you can also have some disadvantages. And I was on, a long conference call with a customer that was doing just this to some very, very expensive, high efficiency speakers that he is putting some of our best cable in, and warning him, okay, well, fortunately, he has access to the crossover. Here's the parts that you're going to buy, and here's the things that you're going to listen to and move when you do this to the cables. Because I can almost promise you, you're going to need to revoice this. Here's how you're going to do it.
Hmm.
You're absolutely correct.
Yeah, that's kind of what I figured. One last question before we go. Off topics of speaker cables. As for your HDMI cables, it's basically a digital cable, ones and O's. Why would I? Why would I get a benefit from going from like a silver cable or spending $1,000?
You won't, and we're a bunch of frauds. When, again, it's the same damn problem. Like in audio, it's sort of like, I hook it up to the signal generator. I got the oscilloscope or the spectrum analyzer on the other side. I got these theoretical matched impedances that never exist in the real world. And I put, like a couple of tones in it, and everything's perfect or everything's the same within these teeny insignificant, degrees, in the readout, and therefore this is a bunch of crap. And then you go to the digital world, and it's like, well, it's all zeros and ones. Of course, I've been hearing about it's all zeros and ones for a number of decades now. I go back to the original 3M 12-bit open reel digital tape machine. I was in the studios when that thing was brand new, and we were told zeros and ones. Throw away your analog machines. This is the future. This is perfect, and there's nothing but distortion to be had in that analog machine. But later on, we went to 16-bit, and then we went to 24-bit, and now you can do non-PCM pulse code modulation 30-bit, and there's also all kinds of different filters and all kinds of different types of dithering schemes, because it would seem that zeros and ones keeps attaining different levels of perfection, because like everything else in the world, nothing's perfect, including those zeros and ones and the technologies around them. It's a false dichotomy. But here's the thing. 99% of what you're hearing with a digital cable, it's noise, just like everything else. It has nothing to do with the zeros and ones. The zeros and ones and the packets are going to come out the same way that they came in. The only thing that can happen is with enough jitter and so forth, the time relationship of those zeros and ones can be skewed, and that matters. It matters mightily. But even if you're lucky enough to where you have analyzed that and it's still pretty decent, the problem is that a digital cable is a noise Trojan horse, because even if the zeros and ones in a sense don't care, and you've got circuitry that can tell the difference between a noise artifact and a 0 and 1, should be able to, for God's sakes. But the thing is that that noise is brought along to one part of the system, to the next component, to the next component. As long as you've got conductive materials, this is what's going to happen. And this is true of your metal chassis and everything else like that. Eventually, it's going to find its way to a D-to-A, a digital to analog converter. And once that hits, that parasitic noise that came along for the ride, you got a problem. So we want to dissipate that noise and turn as much of that noise into heat before it gets there as we possibly can. The more linearly, the better we do with that, the better resolution you have. Yeah, your zeros and ones, we can't really affect. It's what you don't see that matters. The test has to be right. The paradigm of what you test has to be understood, and it's not.
Right. All right, Garth. Well, Garth, thank you for joining us today.
Oh, it was my pleasure. Thank you so much, Shane.
Yeah, and guys, thanks for watching the podcast, and let us know in the comment section down below, what cables do you guys use? Do you guys use AudioQuest? Do you guys use something else? Do you guys make your own? Leave a comment and let us know. Again, Garth, thanks for joining us. Thanks for answering all the questions that jumped at you, and
My pleasure.
hopefully we'll get you on here soon again.
Absolutely. Thank you so much, Shane. I really, really appreciate it. Bye, everyone.